Hi everyone, thank you for joining in today. So I'll be taking you through today's session. My name is Bethany Jepchumba. I am a cloud advocate here at Microsoft, and our today's session is about anomaly detection. So we'll be talking about the anomaly detector in Azure and how you can be able to detect anomalies, what exactly the anomalies and how you can be able to detect them. Before I continue and dive into the session for today, maybe a reminder that we're doing the Cloud Skills Challenge for this period. So the Cloud Skills Challenge is at aka.ms/GOL AI Challenge and will be pasted in the chat. So with that link, you can follow along through the whole lessons and modules that we might have covered throughout the whole Game of Learners period. Additionally, you can see on the screen is a link to today's Learn module. So a Learn module for the day, also a link will be posted in the chat, so you can also follow along and just understand what exactly we're doing and so on. Our session today will be a bit short, so we might not cover the whole hour, but yeah, follow along and you'll learn about anomalies, what are they, and how we can detect them using the anomaly detector. Some of the prerequisites to today's session is at least some basic familiarity with Azure. If you've been with us through the previous sessions, I think by now you already know what Azure is and you can be able to navigate through the Azure portal. The other thing is being able to understand what exactly the Azure Cognitive Services are. We dove into depth on this during the NLP and computer vision topics. So I'm also pretty sure that you understand what they are. But in case you do not, the cognitive services are just services that help you add AI to your different applications. So, for example, if you want something like speech, you want translation, the speech service. If you want something like vision, use the vision services. You can also use things like the face service, as well as knowledge. I think knowledge will cover next week, and now today we'll cover the Azure Anomaly Detector. Our objectives for today is to just understand what the anomaly detector is. By the end of this session, you should actually be able to briefly describe how the detector works and, of course, when to use the detector. The agenda of the day is basically the same: understanding what the anomaly detector is, how it works, when to use it, a demo, and finally, we'll, of course, do a knowledge check to check if you actually understood what you're doing, and a summary at the end. So, as I introduce, maybe I like telling a story about anomalies, but before I tell the story, maybe you can help me with this joke. What do you call a dragon that failed medical school? So, as I tell my story, you can press on the chat what ideas you have. It's based on a pattern. So, if you identify the pattern, you can be able to figure out the answer to the joke. But then, as you figure it out, let me tell you a story. So, when I was in campus, I got my credit card for the first time, and it was something very new, and I rarely used it because most of the time you normally prefer during those times, you normally prefer using cash over your credit card because of the fear of, oh, it might be stolen, insecurity, and so on. So one day I used it and I lost it. And because it's not something that I use every other day, it wasn't something that I noticed until later on. So a few weeks later, I got a call from the bank and they're telling me, we're seeing some transactions being done on your account. Are you the person who's doing the transactions? And I was like, it's around 10 p.m. in the evening. Why would I be doing any online transactions at that time? Probably now I can see myself doing that, but at that time I had never done any online transaction because of the fear of it might be insecure, the sites might not be the best at that time. But then that was something that they noticed as an anomaly, and they gave me a call asking me, is this really you using your card right now, or is it someone else? So that's an example of an anomaly. And because I've not seen anyone who's typed on the chat answering my joke, so this joke is based on a pattern. So what do you call a doctor In normal situations, a doctor, you just call them a doctor, or the initial goes DR. So the initial is DR. So a dragon that failed medical school is an argon. So if you notice the patterns that already exist, you can be able to foretell where the joke is going, right? So an introduction to anomaly detection is when you use AI to determine whether the values in a series are part of the prediction. So in this joke, you can be able to tell there's a pattern going on somewhere. So they're talking about medical school. Medical school, if you pass, you become a doctor. If you fail, you're no longer a doctor. So what makes a dragon a doctor and what makes an argon not a doctor? Of course, it's in the title. So with this, you can be able to analyze values within a series. And most of the time, when you're doing anomaly detection, you have values over a period of time, over a period of months, of years, or even weeks. All this data you've collected, and you can be able to tell when probably the value that's there is over or under the estimated. So, for example, if you use a smart machine to monitor the temperature of a place, and then suddenly the temperature of a building goes above and beyond. So, for example, the building is normally at room temperature between 28, 30, and then all of a sudden you see it's reading 40 degrees Celsius, and you're wondering, okay, this is an anomaly. Other places where you use anomaly detectors is places like when you in medical field, when you're monitoring things like blood pressure. So to be able to identify whether someone either has high blood pressure or the pressure is normal. So by testing every other week, you're able to identify whether the patient's pressure is high or low. The other thing is in products, let's say hardware products. This is still part of IoT, and you're trying to figure out, okay, is this product okay? Is this product failing? How's the product doing? And the last one is when you're comparing prices over expenses over months or something of that sort. So for now, when the economy is on a all-time high and inflation is high, you can be able to see the anomalies because what you bought last year at a time like this and you're buying it this year at a time like this, the cost may be higher and above than what you expected. So that's also an anomaly. An anomaly detector comes in now when you're trying to detect all these changes in the patterns. So when, for example, in this image, you can see it has there are two different shades. So there's a straight line in a dark shade of blue, and then there's a light gray, light bluish shade. And the later shade shows you like the expected values over time. So probably this is what they expect in case like the stocks or the values rise. This is like an estimate of how it will look like. But then you can see this one now, the dark blue now is the actual predicted values. And in the actual predicted values, you can see it's outside the area of the prediction and they're marked by orange. So it shows you that these points are not part of they're not part of the value, the range that you had predicted for those values to be earlier. So the lighter shade of blue is called the sensitivity area, and that's an area whereby you're specifying, okay, this is probably an estimate of where the values will be. So in case you're doing something like market predictions, you know the values probably the cost of sugar will go between 100 to 200 shillings. If it exceeds that amount, then you're like, yeah, there's an anomaly happen. If it goes above 300 or goes below 100 shillings, there's an anomaly and so on. So anomaly detection is just you being able to identify events, being able to make observations, and promptly noticing when things go wrong, promptly noticing when probably your device is about to get to have a failure of some sort and so on. The Azure, this is generally how an anomaly detector works. What about the Azure anomaly detector? I'm not sure why my slides, but yeah, they're moving. So how exactly does the Azure Anomaly Detector works? So this is a service that, of course, as we mentioned, analyzes the different anomalies and patterns, the different, when you've already stated your boundaries, what are these items or values that occur that are different from where you had initially stated they'll be. So it just helps you identify the anomalies that occurs in a stated boundary. For example, in this video, it shows different boxes, probably in a manufacturing company. And if one of the boxes was somewhere in the middle, it will probably ring an alarm and tell you, no, this is a problem happening here. How do you use the anomaly detector? So you take your data and convert it to something called a JSON format. And a JSON format is just a format when you it's just a format of how your data should be collected. So there's of course the tabular form using data frames and Excel file or CSV file, but then using JSON data, this is just a format where you can convert your data. I'll show you an example during the demo. But then once you get your data, by default, it can calculate the ranges. So probably an expected value, the upper and the lower margin of the values. So in the image that I showed you here, see it shows it shades a place, not necessarily shading like a straight line or something. So by shading a place, it's giving you like the upper limit, the lower limit, and probably the expected value that you expect it to be at. And using that, it can be able to estimate, okay, these are probably the margin scales that the data is supposed to be. So the mathematical formula for this is the upper boundary is equals to probably the expected value plus 100 minus the margin scale multiplied by the upper margin. So that's just a mathematical formula. Of course, you wouldn't need to use the mathematical formula here because we'll be just using the anomaly detector, but it's good to understand how the anomaly detector works. So in case you get your data not being consistent, so probably you have missing values, or your data is just not as good as you wanted it to be. Of course, this is with real life. Always data is never as good as you'd want it to be. It might have some missing values or some repetitions and so on. So what you can do is something called sampling. So sampling is every 10 minutes, every few minutes, you have your data, and if it has like 10% of the expected number missing, it's now like it can be able to calculate with it. So if it's like after a few minutes, your data is probably missing. So if you're collecting like hour by hour data and you realize it's missing like 3 out of 24 hours, yeah, it will still be able to compute and give you an idea of how your data should be. But then if it has more than 10% missing, you can be able to fill in the data. So doing something like using a linear interpretation method to fill the data, just ensuring that at least you have a consistency in your data. And if you're doing calculations with it, you can be able to make the right predictions. Um, when do you use such anomaly detectors? I've given you a case, for example, in a bank scenario. And in a bank, this is like real-time data. So this data is coming in, happening as everything is going on. So at the same moment someone is probably using my card on the other side, the bank can be able to notice, oh wow, this shouldn't be happening. Or when you're testing your hardware devices. The other thing is probably when you're doing batch processing of your data. So batch processing is when you collect your data beforehand and then you just come and feed it and see how it will compute at the end of the day. So it supports both methods, both batch processing of time series data and last point for like real-time data. So if you have real-time data, it's good. If you have the batch data, it's good. And what does patch detection involve? So this is just applying the algorithm to the entirety of your data at the same time. This is what we'll do today. So we'll be able, we already have the data. So the only thing we'll be doing is being able to just check, okay, is this data okay? Does it fit on the trend and so on? So there's flat trend time series data. So this is like, for example, if you have like the occasional spikes and dips and so on, but the trend is just technically a bit linear and easy to understand. And then there's seasonality, and then there's seasonal time series data. So this is in seasons, so probably occurs in different patterns. So for example, for flat trend time series, it's continuous, and it has, of course, some dips and spikes. But then with seasonal time series data, it has probably some anomalies on occasion. So for example, for my bank, again, I'll use my same example. For my bank account, it's like a very continuous, this person has never used online banking before, so it's like, okay, which websites are they using to do the payments? Is it a secure place to use it? Then it's now giving you an output. Okay, so let me finish the last explanation and then answer the question on the chat. The other thing is it does real-time detection of your data. So real-time detection is when data is happening as you speak. So in this scenario, probably something like a beverage industry whereby you want to check whether the bottles might be broken or the bottles are well sealed and so on. So this is real-time data, and if you want to ensure that whatever you're producing or whatever how your health is being monitored it can be able to detect anomalies at that point. So this is your go-to type of detection to use. Okay, so the other thing is going directly into the exercise, but I'm seeing a question on the chat. And the question is, how can we detect anomaly data with such a curve? So as I mentioned, there are two curves in these diagrams, and the darker shaded area is a prediction of how you expect your curve to go. And then the line is now what is predicted. So what happens at that time? So for example, you already know, like for let's go back to like a marketing scenario. So you already know how many sales you have at a given period of time, and you can be able to estimate in future how many they will based on the past data. So you have like a range here. Of course, it has like, it's a big range, but not it's not like a straight line, but a range here where you can be able to tell, okay, this is where the marketing data is supposed to fall, the sales data is supposed to fall. But then sometimes you might realize, okay, does not fall within the premises that we had predicted for it to fall under. So what do you do? So this is where now the anomaly detector comes and tells you, okay, there's a danger sign here. Probably you'll check and see why you had bad sales. Probably it might be due to a reasonable reason, like probably there was inflation during that period, so sales wasn't as good. But then it might also be a red flag. Probably there's something that is wrong with the production system, and you have to check on it. So that's how you are able to detect. You're able to detect the anomalies in such a curve. Okay, I don't think there's any question, so I'll go directly to the exercise. And with the exercise, I'll be creating an anomaly detector. And then with the anomaly detector that we create, we'll run through some code and check to see if it actually can detect anomalies. So the first thing we do is, of course, go to Azure portal. So portal.azure.com. And the easiest thing to do is just search the resource you want, or you can go to create a resource and search from there. So anomaly detector, anomaly detect. I hope I've spelled it right. So yeah, anomaly detector. This is ours, the Microsoft Azure service, and this is the service we're going to use. As you can see, it helps you foresee problems before they occur. So using already known data, it can help you predict the future in a way and see if you might have some pending problems that might occur. So as usual, we'll go ahead and create our resource. So I'll use, oh, sorry. So yeah, I'll use my subscription, and then resource group, I'll use my demo AI resource group. And then from the resource group, our region, my region, I normally use West Europe, and then the name. So I can do anomaly detector demo, and then my name at the end. The pricing tier, of course, you can go the free pricing tier because it's of course free. But if you already have other resources, you might only be allowed to choose the standard. It will just go with the free, review, and create. So we'll give it a minute as it validates. So I've agreed to the legal terms and so on. And once its validation is passed, you can go ahead and create your service. So as it creates, let's go to the repo that we'll be using. So let me get the link. The repository that we'll be using is, oh, sorry, is the AI 900. Okay, copy to the wrong thing. So it's the AI 900 resource that's on your, the link is on the exercise. So it's making me, let me use my other browser so that I can be able to log in to the account. Okay, I'm not sure why it's not giving me the right link that I'm looking for, but this is the repository that we'll be using. Probably it's because I was already git cloned it, but yeah, I'll check on why the problem is there. But once your deployment is complete, you can go to the resource and you'll be able to see you've been able to create the anomaly detector. In our case, we'll use the API key to authenticate, but you can use it in different languages. So in things like Python, Node.js, and C Sharp, you can be able to use the API key using the endpoint and make a call to the Git, make a call to the anomaly detector. So I'll go to VS Code, and in VS Code, I'll copy, I'll copy the link to the repository. So the repository is, oh yeah, I'm seeing the issue. So it's GitHub. Let me copy paste it again and see if I can be able to access it now. Yes. This is the repository that we'll be using. And in this repository, as you can see, it has like different things that you can do. It already has the data in there. And what we'll be doing is detecting anomalies. So that's the exercise that we'll be doing. So yeah, in the exercise, you'll find this repository and you can go ahead and copy paste. So I'll be using VS Code to access the repository. And the first thing, of course, is to git clone the code into my local environment. So git clone the repository. It will take a second to clone the entire repository into my local environment. But as it does that, so let's look at the data that we have. And the data we're using is an anomaly. And as I mentioned earlier, the format that the data takes is a JSON format. So this format shows you how a JSON format, this is the JSON format. So it has like the series, and then under it you get like the different values in the series. So for example, as you're doing, probably you calculate, this is a unit of sales, and it's between the years 1972 all the way to 1975. So every month it's telling you like the sales they reached in that year. And as you can see, all the values are inside the series. So the first thing is defining like what the series is, and like the value and the timestamps for each. Then the other things you're defining is probably the ratio for the anomaly, the sensitivity, and how often the anomaly takes place. So for example, for us, we're going with monthly, the sensitivity is 95 and the anomaly ratio is 0.25. So that's the data that you're dealing with. And with this data, we'll check to see if out of the results that we get here, out of the results we're getting, if there's any anomaly here. Let's see if our data has downloaded. Yes, our data has downloaded. So I'll go into the data and then open up the code for it. Okay, so it's opened the data in my local file. And as you can see, what we're trying to do is detecting the anomalies. This is in PowerShell script, so if you have any challenge running it, you'll have to install the extension, the PowerShell extension. I'm using a new device, so I literally don't have any other extension other than the PowerShell extension. So with this, you can be able to run your PowerShell code comfortably without even like having any issues. And this is the code that we have. So we have you defining what your keys and endpoints are, writing now, uh, and then, so this is you now, after you've defined your keys and endpoints, you write the code to analyze the data. And the first thing you have to do is adding the headers. So adding the keys and endpoints into your headers, getting the data, as I've shown you the data, getting it into JSON, and this is the data. This is you ensuring the data is raw in JSON, and then in the results you get, analyzing it and see whether you'll be able to detect any anomalies there. So the URI, the endpoint is the anomaly detector. Header, this is where the keys and the endpoints sit, and of course the data. And then once you've been able to analyze it, you go ahead and process the results. So check to see if there's any anomaly. If there's an anomaly, you have it in red. If there's none, just leave it as it is. So I'll go ahead, I'll go back to the code I'll go back to our anomaly detector and get the keys and endpoints. So I'll come here, get the keys and endpoints. So I'll ensure I delete this after the session because, oh, so sorry. Yes, I'll ensure I delete this after the session so that it's not misused. But this is my key, so I'll just paste it here and then go back, get my endpoint and paste it here. Then what we want to do is to run the code to see if it will give us any anomalies. So we stated that if there's an anomaly, if it's true, have it in white. If not, have it in red. If not, leave it at white. So I'll go to detect anomalies and let's see what results we get. Analyzing the data. Okay. Then yeah, we see there's one anomaly here, but the rest are good. So the rest of the values lie between 700, I think 760 all the way to 961. So that's the range. Oh yeah, this is 966. So that's the range of the values that we have. But then this one is at 1030, which is a very high value. And probably if it's a sales, this might be a good thing. But if it's something like predicting the number of errors that you have in your code or something, this might be such a high number. So that's it about detecting anomalies. You've seen from the code how you can be able to, this is PowerShell script. So if you write Python, if you write Java, or whichever other language you write, you can be able to go back to the documentations and see how to twist your language, and get to read the anomalies from the same data. But this is basically how you can be able to analyze the anomaly. And as you can see at the end of it all, we've been able to analyze and see that yes, there was an anomaly and it's in red. So it's like, yeah, this is a very dangerous anomaly. We must check it up first and so on. So yeah, that's it about anomaly detection. I'm not sure if there's any other question. So there's a question by Motizus asking if the session is being recorded. So yeah, you can still find the session here. It's recorded, and when you come back again here, you'll be able to find it. I don't think there's any other question from the audience, but as I said today, our session will be very short. So we'll go right into the me asking you questions to see if you've been able to grasp what I was teaching today. And then after that, we'll call it a night, or an evening, or a day, depending on where you joined us from. So let's head on to the knowledge check. The knowledge check is just us checking to see whether you've been able to understand, and you can just drop your answers A, B, or C. So the first question is what is meant by seasonal data? So seasonal data, I explained earlier. So what does seasonal data mean? And does it mean data based on the time of the year it was recorded? Or does it mean how far apart the values are by default for each recorded period? Or lastly, does it mean data occurring at regular intervals? So what is seasonal data? Everyone is giving C, Sahil C, Fortune C. Anyone else? I think everyone got it. So yeah, the answer is C. The seasonal data is just data that has a pattern. So data that you can be able to tell, yeah, there's a pattern in this data. It can occur either hourly, daily, or monthly in patterns. So for example, in seasons, we have the weather patterns, normal weather patterns that we experience. Depending on where you're from, you might experience summer, winters, fall, and spring. All those are seasonals. So seasonal data is something that occurs at regular intervals, and you can see the pattern in the data. The second question is, what is the purpose of specifying granularity granularity in your JSON data object? Give me a second, I drink some water. Yeah, the question is, what is the purpose of specifying granularity in your JSON data object? Is it to indicate the recording pattern of the data, or does it tell the service how to chunk up the results that are returned for review, independent of the time series data pattern, or is it used to indicate the range of acceptable values? So what is the purpose of specifying the granularity? So I want to explain what granularity is, but let's see if there's anyone who knows the purpose. So is it A, B, or C? I can see Sahil saying A, Karani saying B. Anyone else? Okay, let me show you something that we saw in our data so that you remember what granularity is. It was under Anomaly, our data.json file. Let me zoom in a bit. And you can see we specified the granularity at the bottom. And the granularity was in months. So we're saying, hey, the data was monthly data. So what is the purpose of specifying granularity? The answer to the question, let's see. The answer to the question will be A. It is used to indicate the recording patterns of the data. So as you've seen, our granularity was monthly. So it's telling our API that this data we have been recording it in a monthly period of time. So yeah, it's used to indicate the recording pattern of the data. It does not tell the service how to chunk up the results that are returned for review, because we want the service to see the series of like the pattern that was there in the data. So yeah, I've seen so many people answering B, so that's why I wanted to clarify that no, it does not chunk up the results, because as you saw, the results that we got, let me see if we can, let me go back to my terminal. See, it does not, the results weren't like divided saying, hey, this is month 1, month 2, month 3. No, it was just used to tell the data, okay, this is how we recorded our data. And then the last question for the night is, how does the anomaly detector service evaluate real-time data for anomalies? How do you use it to detect now? For example, if our data, we're recording it in real time. So if you're directly checking the heartbeat of a person, how does it tell that, hey, this data has an anomaly? A, does it collect all the values in a window of time and evaluate them all at once? Does it evaluate the current value against the previous value? Or does it use interpolation based on the current value and the previous value to predict what the expected value should be? Okay, so there's B, evaluating the current value, but then there's C. So let's see what the answer is. The answer is it evaluates the current value against the previous value. Remember, this is real-time data that you're collecting. It means that you do not have a large chunk of data that you're collecting to see if there's any differences in the data. So real-time data, interpolation based, we normally use it when we already have like the batch data and we want to predict, okay, this is what we think the future data might be. But if you're just using a real-time data, you're evaluating the current value against the previous value. Okay, I think that's it for my questions. I'll go ahead and summarize. I'm not sure if anyone has any question. So as I summarize, you can be posting your question. And yeah, I think that would be it for today. So in summary, the anomaly detector, of course, detects anomalies And we said anomalies is being able to see the patterns in data and see whether there's a pattern that's not supposed to be there in a way. So it supports two basic detecting models. One to detect a batch data of which the model is trained by time series and then sent to the service. The other one is using to detect the last of point model. This is when you're doing real-time data. So with real-time data, as mentioned, use the previous value to predict whether the current value has any issues or not. And then one thing we mentioned was when you're doing your data, you have to package your data in a JSON format to be able to enable the API to detect the anomalies in a time series data. So remember, most of with the anomaly detectors, we are generally dealing with time series, dealing with changes in time periods and so on. So of course, you have to ensure your data is in time series and the format is JSON. And then with that, you can be able to identify if you have any issues with the data or not. You can use this API in your different languages and you can integrate it as a REST API. So depending on how you call which language you code, how you call your data, you can use it make REST calls. The other one is adding an SDK to your code. And SDKs, there's availability in Python, C Sharp, and I think Node.js. So you can be able to use both methods. And yeah, I think that's about it. I hope you've been able to learn a lot in this and you can be able to expand your machine learning knowledge. As I mentioned before, we're doing the machine learning, we're doing the Cloud Skills Challenge, aka.ms/GOL AI Challenge. And in that challenge, it's about 9 days to the end of the challenge. So that's something that you should consider doing. Everyone who finishes, of course, will get a badge at the end. We also have our last session on Thursday. The session will be about decision making and data mining. So be sure to join in and learn about the Azure Cognitive Search Service, how you can go through documents. You can use AI to go through documents and find relevant data that you might need. So if you have like your notes set aside and you're studying for exams and you want to use AI to help you find the relevant notes that you need, probably that's something you can start doing. And then the last thing is be sure to go through today's module. Link was also posted earlier, so ensure you go through it, learn a bit, and yeah, that is totally it from myself. I'm seeing one last question on the chat asking whether I said badge or bag. I said badge, a digital badge that you can post on LinkedIn and your social networks to show that you've been able to learn Azure AI for these past few months. Otherwise, thank you so much for joining in and see you in the next session. Bye.